So good day everyone. Today we want to consider types of reaction. It is a very important study in chemistry, and the knowledge is important in knowing so much about writing equations in chemistry, balancing chemical equation, and knowing why the product, a certain product will be obtained during a chemical reaction. Well, there are several types of reaction in chemistry, but the following shall be considered: the combination reaction, decomposition reaction, displacement reaction, double decomposition, catalytic reaction, thermal dissociation, and redox reaction. And so let's take the very first one now, combination reaction. You know, just like the name goes, combination. When two or more things combine together, that is combination. And so combination reaction is simply the type of reaction which involves the combination of either two or more elements to form a compound, or two or more smaller compounds to form a bigger compound. What do I mean by this? Let's illustrate now. E.g., let's say we have iron, which happens to be a solid, plus sulfur, which also is a solid, combining together. This will give us iron 2 sulfide. Now, this is an element combined with another element to form a compound. This is a combination reaction. We have another case where not an element now, but a compound combining with another compound, such as SO2. You see, this is lead 4 oxide, and this is sulfur 4 oxide, combined together to form lead 2 tetraoxosulfate 6. And so now this is a combination reaction, but this is no longer an element but a compound combined together to form a bigger compound. So that's that about combination reaction. And so the second one is the decomposition reaction from what we have here. What then is the decomposition reaction? Well, this is the type of reaction which involves the splitting of a compound into two or more compounds. You see, if it is involved, then it is called thermal decomposition. And so let's take an example now. Let's assume we have lead 2 triosnitrate 5, and when this is heated, this breaks down into lead 2 oxide plus nitrogen 4 oxide and then plus oxygen. Then we balance the reaction. Okay? So this is a balanced reaction for lead 2 triosnitrate when it's heated. Split into lead 2 oxide, nitrogen 4 oxide, and then oxygen gas. And so that's that about that. Now we'll take the next one, displacement reaction. So displacement reaction. This type of reaction involves displacement of one element by another, or the displacement of one radical by another. You see, this type of reaction is very, very important, as it helps when you are giving a chemical reaction. You know what the product should be, even when you are not giving the product. Seeing the type of reaction it is, you could tell the product. Well, something is very, very important here, and that's the knowledge of the displacement power of the cations and anions. And this is it here. Actually, this is called the activity series. So that's another name for it. It shows you the displacement power of the ions. So let's take an example, for instance. Now, let's say we are given zinc plus copper 2 tetraoxosulfate 6. What then should be the product? Well, this is an element here, and this is a compound here. Actually, if you look carefully, zinc is a cation. That's zinc here, a cation. And then here we have two ions present. We have the Cu2 plus, this is it here, and then which is a cation, and the SO4 2 minus, which is an anion. Now, what will happen here is that zinc comes to displace copper. Zinc will never displace SO4, but displace copper, because a cation can displace its fellow cation in an equation. So what will happen here now is that zinc displaces copper. And so if it removes copper from here, it attaches itself to the SO4. Now how do you write that? Some goes along to just write ZnSO4. But I miss it for students. And the reason why I do is because you must check if that's how it should be written actually. So this should be written as, you know that zinc now want to combine with SO4 because it's displacing copper. You write it out. This is zinc and it want to combine with SO4, 2 minus. This is 2 of this one, 2, and this is 2. I'm writing out their valency. This is 1, 1, meaning that it can be broken down to 1, 1. So zinc 1 zinc and 1 SO4. So this will be ZnSO4. And mind you, when you write this, you don't put the 2 minus or 2 plus for the zinc and the SO4 again. Now plus, it means that zinc has removed copper and replaced copper in this compound. And then copper will now stay displaced alone like this. So this is how the equation should be. Let's take another illustration again. Let's say we have sodium plus calcium triazocarbonate 4, for instance. What then would happen in this equation? Well, sodium comes to displace calcium. And why would that happen? That's because sodium is above calcium in the activity series. So the reason why zinc displaces copper here is because zinc is above copper in the activity series. The same way too, sodium will displace calcium here and marry the CO3. How will you write that? You're not going to just write NaCO3. I'm sorry, you are wrong in this case. If you are writing that in this first one, you might be right and you're actually right, but that's not the right step. But see now, for this you are wrong. Why? Because you are saying sodium now wants to combine with CO3 2 minus. This is 1 and this is 2. If you do like this, you see that you need 2 sodium. So how should you write it? You write like this: Na2CO3, then plus. Now, calcium is being displaced. How will you write it? Ca. That's the answer. And so let's take another illustration, for instance. I remember I made this question in one of the JAMB past question, and it says that Cu plus ZnSO4. A question in this format, I'm not sure of the question exactly, but in this format, and what should be the product? And somebody will say copper is coming to displace zinc. That's actually impossible. That's because copper is beneath zinc. And that still tells you that in your laboratory, because students see the reaction and they don't know what goes on in any reaction. You see, if copper, you take a piece of copper into a zinc tetraoxide, nothing would actually happen. That's because copper cannot displace zinc. So here, no reaction. And that's why I say this study is very, very important, because its knowledge guides you in writing chemical equation. So that's that about that. But in this first case now, when you take a piece of zinc and put it into copper 2 tetraoxide, you do realize that reaction takes place. And this compound, copper 2 tetraoxide, actually has a blue color. But when zinc is put inside, the blue color disappears. That's the way that reaction has taken place. But nothing happens here. You only see the copper you put into the zinc tetraoxide to be just bouncing up and down, because no reaction is taking place. Let's take another example again. Let's say we have fluorine gas plus HCl. What then happens here? Here, fluorine cannot displace hydrogen. Why? Because fluorine is an anion and hydrogen is a cation. And so fluorine would only be able to displace chlorine. And being above chlorine in the activity series, fluorine will displace chlorine. And this is how it happens. You are going to write, fluorine now want to displace chlorine to marry the hydrogen. You have to write it out actually. Let's clean this now. So this is what we do now. You say hydrogen, the positive, you always write the positive. Now want to get married to the fluorine. This is 1 and 1. 1, 1. This is going to be HF. Then plus, next, the chlorine is being displaced. Whenever fluorine is displaced, which is almost impossible, or chlorine is displaced, which is what happens here, or bromine is displaced, or hydrogen too is displaced, to stay on their own, they exist as gas. So I'm going to write chlorine, not just Cl, but Cl2, because they're going to become gases. And then you balance the equation now. Well, 2 chlorine is used here, so you should put 2 here. And if that happens, 2 hydrogen is not being used, you put 2 here. The equation is not balanced. I think I didn't balance this equation here. There ought to be 2 here. So that's that about that. Let's take another one now. Let's say we have sodium combining with H2SO4. What then will be, this is the last one I will be taking now. Here, sodium will displace hydrogen. Sodium displaces hydrogen, and that's because sodium is above hydrogen activity series. But how do you write this? Just NaSO4. No, you will be wrong. Actually, right? Sodium wants to marry SO4 because it's displacing hydrogen. This is 1 and this is 2. So you write like this and like this. So this will be Na2 because you need 2 sodium and SO4. And then the hydrogen being displaced would always be a gas, like I said earlier. This is H2. So that's that about that. Then balance the equation. We have 2 here. So that's that about that. Let me ask you this. You can try this on your own. What happens here when chlorine combines with sodium fluoride, for instance? Can you tell me the product that will be formed? Okay? Well, not to waste time. You can pause the video and try. But actually, no reaction takes place here. And that's simply because, if you look carefully now, chlorine is not coming to this sodium because they are not like ions. This is an anion, you can see that here, and this is a cation. So it's only coming to displace fluorine. But being lower than fluorine in the activity series, it cannot displace fluorine, so no reaction takes place. Okay, so we're looking at the very fourth one now, the double decomposition. This reaction simply involves the exchange of radical. This is another very important type of reaction. You need the knowledge of this. The knowledge of the displacement reaction, the knowledge of the double decomposition reaction are important type of reaction you need to know in order to write a chemical equation. Okay, now take note now. Let's say for instance we have AgCl plus NaNO3 here. What happens here? Well, what will happen here is the exchange of radicals. What do I mean by that? You see, silver has its own radical, which is the chlorine, and sodium has its own radical, which is NO3. This is not the same as the displacement reaction, because in displacement reaction, one of the substance is coming to displace because it doesn't have its own radical. For instance, now look at this. Let's say I have sodium plus HCl. This sodium is not combined with another radical, it's just isolated alone. So it's coming to take the chlorine radical from hydrogen. That's different from this because silver has its own, sodium has its own. So what will happen here is that they will exchange radicals. Silver will say, I'm tired of this chlorine radical. Can I come and take NO3? And sodium will say, I'm tired with this NO3. Can I come and take chlorine? And that's what happens here actually. And so silver combines with NO3. But remember, you're not just going to write it that way. You're going to say silver Ag plus. And that's why we just need this to now you write Ag plus. So you have to have this on your head. Very, very important. Plus coming to marry NO3. And you should know how NO3 looks like. Triazonatate 5. And this is it here. So 1, 1. Obviously, this is going to be AgNO3 because you need 1, 1 of this. Now, sodium is coming to marry chlorine. And how do you write that? Na plus Cl minus. This is 1, 1 as well. So this is going to be plus NaCl. Then you look out if the equation is balanced. So the equation is actually balanced here. Let's take another illustration now. Let's say we have potassium tetraoxosulfate 6 plus, let's say we have HNO3, or let's not use H. Let's say we are using calcium triazocarbonate 4. How is this going to be? Okay, take note now. Exchange of radical takes place here. What I mean is this. Potassium is coming to combine with the radical of calcium, which is CO3. But the radical has 2 minus as its ion. So this is 1 and this is 2. combining together. That will be K2CO3 plus, now here calcium is coming to take SO4. And how is that going to look? Ca2 plus SO4, 2 minus. So this is going to be 2 and 2. And this can be broken down into 1 and 1. So 1 calcium, 1 SO4. That is CaSO4. Then we'll look at if it is actually balanced. And it is balanced actually. Let's take another illustration. Let's say we have NaCl plus magnesium. Let's say magnesium triazosulfate 5. Sorry, triazosulfate 4, not triazosulfate 5. That's a mistake. Now, sodium is coming to combine with the SO3. And how will it look like if you do this carefully? This is 1 and this is 2. You're going to have Na2SO3 plus, now magnesium is going to combine with chlorine, Mg, 2 plus chlorine minus, this is 2, this is 1. This is going to be MgCl2. And so that's that. And then you try to balance the equation. Where 2 sodium is used here, you put 2 here, 2 chlorine now, and then 2 chlorine. So the equation is balanced. So that's now about the double decomposition. This is so important at times. The knowledge is needed in precipitation reaction. But I don't want to talk about that because you also need to know soluble salt and insoluble salt to know which compound will precipitate and which one will not precipitate and all that. But this is double decomposition and quite easy. So, catalytic reaction. A catalytic reaction is any reaction which involves a catalyst. Now, what is a catalyst? A catalyst is a substance which alters the rate of a chemical reaction. Understand that a catalyst that speeds up the rate of a chemical reaction is known as a positive catalyst, while a catalyst that slows down the rate of a chemical reaction is known as a negative catalyst. Some people often say that catalysts are substances that speed up the rate of chemical reaction. That's actually wrong. They're actually defining a positive catalyst and not catalyst. Catalyst actually alters. It could speed up or slow down. Okay? Now, there are certain substances that they are not catalysts in themselves, but they improve or reduce the efficiency of a catalyst. And they are known as promoters or inhibitors. A promoter is actually a substance that improves the efficiency of a catalyst. A good example is the ion used in the ABBA process. Now, the ion is activated by aluminium oxide. The aluminium oxide now is not a catalyst. The ion is a catalyst, but the aluminium oxide helps to improve the efficiency of the catalyst, which is the ion. So the aluminum oxide is the promoter itself. Now, we also have substances that slows down the efficiency of a catalyst. Those substances are called inhibitors, or you call them catalyst poisons. So, again, it's enzymes. Enzymes are organic catalysts. They control biochemical reactions in living organisms. Now, it's important to know that a catalyzed reaction can be divided into two, namely 1, homogeneous catalysis, and 2, heterogeneous catalysis. For homogeneous catalysis, this is a type of catalytic reaction in which the catalyst, the reactants, and the product are all in the same phase. For instance, now look at this now. We have sulfur 4 oxide combined with oxygen to produce sulfur 6 oxide. This process of producing sulfur 6 oxide is known as contact process. And here, the nitrogen, the catalyst uses nitrogen 2 oxide. But you understand that they are all in the same phase. A gas, and the catalyst also a gas. So this is an example of homogeneous catalysis. We also have what we call heterogeneous catalysis. In this type of reaction, the catalyst, the reactant, and the product are not all in the same phase, as we can see in the Haber process now, that the reactant is a gas, the product is a gas, but the catalyst is a solid. And so this is an example of heterogeneous catalysis. So characteristics of a catalyst. A catalyst alters the rate of a chemical reaction. 2, a catalyst remains unchanged quantitatively and qualitatively at the end of a reaction. Meaning that if you use a catalyst in a reaction, the mass of the catalyst will not change, and the chemical constituent also will not change, even after the reaction has taken place. Again, a catalyst is specific in action, meaning that a catalyst would only influence one type of reaction, will not influence this reaction and influence the next reaction and influence the next. No. Just specific in action. A catalyst cannot start a reaction. A reaction will not start because you add catalyst to it. No. Again, that it does not affect a chemical reaction in equilibrium. If a chemical reaction attains equilibrium, catalyst has no influence in it. Catalyst can make a chemical reaction attain equilibrium very fast, but once the chemical reaction gets to equilibrium, it has no effect on that reaction. Again, the efficiency of a catalyst can be improved by increasing the surface area. And we know how to do that now by breaking the catalyst into smaller pieces. Again, and lastly, a catalyst affects the rate of reaction, even though it is present in very small amounts. So that's that about the catalytic reaction. Thermal dissociation. This is very similar to thermal decomposition. The only difference is that it involves reversible reaction. For instance, now look at ammonium chloride. When heated, splits or decomposes into ammonium gas and hydrogen chloride gas. And when ammonium chloride gas and hydrogen chloride gas is cooled, it forms ammonium chloride again. And so it's a type of reversible reaction actually, although we've not done reversible reaction. So what then is reversible reaction, which is the 7th one? A reversible reaction is one which can be made to proceed in either forward or backward direction under stable condition. And this symbol here, a forward arrow and a backward arrow, is what is used. For instance, look at this now. We have iron combining with steam to form iron 2-di-iron 3 oxide with hydrogen gas. And this reaction is reversible because iron 2-di-iron 3 oxide can combine with hydrogen gas to form iron plus steam. So that's that about a reversible reaction. It involves a double arrow, one pointing forward and the other one pointing backward.